So this year we are extremely happy to have Mr. Somesh Bandyopadhyay. By the way, he is also a student of the Electrical Engineering Department of Jadavpur University. But right now on his seat, he is very well known. He is now serving as Managing Director of Gujarat State Electricity Corporation Limited. We are very happy that he has spared time to deliver a talk on this very special occasion. And to start the proceedings, I would request the WAST young associate, Dr. Arannak Chakraborty. Arannak, you are here?
He is there.
Yes, sir. Yes, sir. Good evening.
He is there.
So I would request Dr. Arannak Chakraborty to give a formal introduction of our speaker today, Mr. Somesh Bandyopadhyay. Please go ahead.
Yeah. So good evening, everyone. So the title of today's talk is Use of the State-of-the-Art Technology in Indian Power Sector by Mr. Somesh Bandyopadhyay. So I will just briefly introduce him. So Mr. Bandyopadhyay is a 1990 batch electrical engineering graduate from Jadavpur University, and he is presently working as the managing director of the Gujarat State Electricity Corporation Limited on deputation from NTPC. Prior to joining GSECL in October 2023, he contributed in various capacities towards NTPC's transformational journey into a sustainable integrated energy behemoth. Mr. Bandyopadhyay has a career spanning over 3.5 decades of experience in varied fields of power sector in NTPC, including power plant operation and maintenance, renewable energy, hydro, corporate operation services, coal mining, etc. He has also worked at different stations of NTPC across India, which includes Korba, Farakka, Talcher, Sipat, and Vindhyachal. He has also headed the Aravali Power Company Limited, which is a joint venture company of NTPC, as its chief executive officer. Mr. Bandyopadhyay has many laurels to his credit while working at NTPC. He introduced the automatic generation control for the first time in the Indian power sector. He took initiatives to replace coal with biofuel, flexibility in ECR, etc. He is a certified protection engineer by Alstom Grid UK, and currently he is also the chairman of the prestigious CIGRE National Study Committee B5, Paris. So welcome, sir. So
Thank
this
you,
talk.
Arun.
Yeah.
Thank you.
Now over to you.
So while you switch to the PowerPoint, Mr. Bandyopadhyay, just to let you know that we are also streaming it live through the West Bengal Academy YouTube channel. So for that, we seek your formal permission if you allow us to.
Definitely,
Okay.
but I don't have any PowerPoint presentation. Just will be.
That's fine.
discussing.
That's fine.
Okay.
So the floor is yours, and we look
Okay.
forward to
Okay. Thank you so much, Mr. Ganguly, Mr. Arannak. Good evening to all of you who has been online and connected to this medium on this National Technology Day 2025. First of all, namaskar to all, and my sincere gratitude to West Bengal Academy of Science and Technology, and specifically to our Professor Sivaji sir for inviting me on this day. And I am really, truly delighted, honored, privileged, whatever you call it, this opportunity to share some of my thoughts on this topic. I am told to discuss about the topic on use of state-of-the-art technology in Indian power sector. Let me start with some glimpses about the Indian power sector and vis-a-vis the world or the other countries who are the leaders in power sector. and then we will be one by one discussing, rather sharing my experience, how we can implement, or already we have implemented a lot of technology to enhance the efficiency of power generation, power consumption, electric power definitely, and making it more affordable and most importantly eco-friendly. So we'll discuss as we go along, maybe not in a very organized way, but whatever comes to my mind, I will be discussing on that. So coming back to the power sector, as you all are aware of, that India generates almost 1900 or 1800 billion units. It is called terawatt hour, and we call it billion units. And if you look at the world perspective, this yearly power consumption for the whole world is around 30,000 billion units. So our percentage of energy consumption is around 5% or so. It's a very, and being a 1.4 plus billion people's country, our per capita energy consumption is very low compared to the world standard, and even much lower than the world average. So at the same time, you see the installed capacity of our Indian power sector. Our installed capacity recently has touched 475 gigawatt, and the world capacity is around touching more than 9,000 to 10,000 gigawatt. And here the major player is China. They are the stalwart in power sector. Their capacity is almost 1/3 of the world's capacity, whether in terms of installed capacity, in terms of energy consumption, generation, and their consumption is more than 10,000 billion unit terawatt hour, which is more than 5.5 times of India's. So if our economy has to advance at least 4 to 5%, the power sector has to grow more than 6 to 7%. As you have seen, the last year generation was around 5% growth was there. And historically, if you look at the last 10 years generation pattern, the more or less 6.5% is the average growth, barring the COVID period. So we are on right track, no doubt, but our energy consumption level has to reach a certain level where, if we really want to become Vikshit Bharat by 2047 and become a developed nation, our comfort of our life at least it should be near to those countries whose average per capita consumption is around 5,000 to 6,000 kilowatt hour, and we are at 1,400 or 500 kilowatt hour range. So our demand, our energy requirement will jump 4 to 5 times, and it will become around, at least if we want to become a population of 1.5 billion, if we can restrict ourselves to 1.5 billion, then also we require a energy consumption or generation of 10,000 plus billion unit. So where is the source of energies? Historically, what we are consistently dependent and heavily dependent on coal-based generations, and which recently, after the Paris Agreement, which is a legally bounded agreement, has bounded 196 nations to reduce the coal-fired generation, to reduce the carbon emission. We'll come to that. And thereafter, in COP26 at Glasgow, our Honorable Prime Minister has announced our Panchamrit goal, which further updated and revised our target. That is, by 2030, we'll be installing, our install capacity should go, the renewable energy install capacity should touch 500 gigawatt. 50% of our energy consumption should be made from renewable source of energy. And on the decarbonization front, 1 billion tons of CO2 emission has to be reduced compared to 2022. So within these 8 years, our CO2 emission has to be reduced by 1 billion ton. And CO2 and emission intensity, that has to be reduced by 45% compared to 2005 level. And the final one is net zero by 2070. So huge pressure on us. At one hand, the pressure of development, economic development, and the other hand, rapid decarbonization. And both these two are in contrast, they are contradictory. But we'll have to realize this in a manner so that we can have our energy sources, we can have more clean source of energy, and that's why the whole world is going towards, started towards going towards nuclear. Because till now we are unable to find out any other source, sustainable source, which can really replace coal. So only nuclear fission is at present is the only way out to give a base load or sustainable source of clean energy into the grid. And it has to mitigate the flexibility, the intermittency and the variability of the renewable energy sources in the grid. You are aware of the recent blackout in Spain and Portugal and some part of the France. So such blackouts, such disturbances, because of the high penetration of RE, which is reducing the inertia, the short circuit level, lot of issues. The frequency stability is at risk, and we are going to face in coming future such scenarios. Rather, we can think of we are going back to the initial days of our Edison age, when there was all resistive loads and very frequently there was grid outages, no inertia in the system, no frequency control. So with that perspective, a lot of intervention is required to not only provide affordable, sustainable and eco-friendly energy, at the same time technologies have to be applied for the grid control, the smart grid, then comes to the load dispatch. Every areas, transmission, distribution, power generation, every areas, the demand of the day is to utilize and use the cutting edge technologies so that the grid can be made more secure, more efficient, the power supply, and more affordable. Now coming to the distribution sector, government is taking a lot of initiatives through now recently through this RDSS, advanced metering infrastructures, and which will smart meters, which will provide real-time data, which will give you a very good estimation of the load forecasting, and accurate billing and load management. Then supervisory control and data acquisition system is the old technology. It is already there in almost all the areas of the power sector. Then distribution management system, use of everywhere now people are utilizing the AI and ML, and the scope is there. The smart grids, where now the bidirectional communications between the energy producers and the consumers and the operators. Now, because as people are now becoming from consumer to prosumer, the solar generators, particularly everybody is now, that is a government's initiative, has already paved a lot of infrastructural changes in the rooftop solar. Already there has been more than 55% growth in solar rooftop. Almost 15 gigawatt of solar rooftop is being installed. So the net metering and a lot of changes is coming in the distribution sector as well, because of the bidirectional flow of electric power and the consumer's behavior, prosumers. Now coming to the transmission, which is already we have PLCC based protections, we have control, but now more and more difficulties are being faced by the SLDCs, load dispatch centers, RLDCs. And as you know, our penetration of renewable is right now is only 13-14% in terms of energy. So as we go along, if it goes near to 50%, which is our target by 2030, the effect of these intermittent supplies and variable supplies will be very difficult to control without adopting this AI powered software, which can give a quick response to any changes in frequency, and these quick responses, once again, it is very difficult to come from the coal based power stations. But also the next challenge is coming, that with this high integration of RE resources, we need to have energy storage systems. Battery storage is the easy one. Installation and gestation periods are low, and then comes the pump storage. Already pump storage is a proven technology. Battery storage also not a new technology, but a lot of evolvement or changes are taking place. Lithium ion, now sodium ion, vanadium, redox flow batteries. The batteries right now, the lithium iron batteries having the disadvantages of deep discharge, then heating issues, then coming to the cycle of operations, the life cycle operations. So, but still it is required, and that's why every power plant, even the power plants of the thermal power plants, wherever there is land for available, they are coming up with the installation of batteries, grid connected batteries. But the thing is, these batteries have to be used very effectively to not only supply power at the time when there is no RE power, it is to be used for grid control frequency response. And this can be done only through AI based software. Whenever there is a frequency going up, the batteries will be charged immediately, and when the frequency is going down, the batteries will push power, so that some sort of artificial inertia can be introduced, and as well as the frequency can be kept constant. And this has to be done by the load dispatch centers. So all the control of this battery management system must be with the load dispatch centers. Now, so there is a huge scope for utilization of AI powered software in these grid control and load dispatch areas. Now coming to the renewable source of energy, there are a lot of technologies. Every day in, day out, the solar technology is changing. Varieties of solar cells are coming up. The energy intensity is being increased. Now 700, 800, maybe 720 watt peak bifacial modules are available. So every day the changes are coming. We started with around, I think, maybe less than 200 watt peak. Now we have reached up to 720. So the technology of silicon ingot preparation, silicon wafer preparations, and here also we are very much dependent on China. So as for the batteries. So we have discussed about the energy storage and their utilizations. Now coming to the main power sector, main generation sector, where I spend most of my life. Here, when we started our professional life career in the 90s, our motto was only to generate at any cost, the PLF was the mantra, because the country was power starved. But over the years, a lot of power generation has come up, and we have become surplus energy, power surplus, and at the same time, now the responsibility of the power generating companies has come that we cannot become a polluter. We will be punished. The polluter will be punished. So we'll have to generate power in a very eco-friendly manner, and whatever the byproduct, whether air pollution, water pollution, or the soil pollution, that has to be mitigated. So the total perspective has changed. No more PLF. Availability is the main thing, and response to the grid requirement is the main thing. And over the years, when we started, that time all the technologies were electromechanical. As electrical engineer, we used to have the energy meters, the 2 element, 3 element meters, all electromechanical discs type energy meters, protection relays. But within few, within these 2 or 3 decades, it has really shifted and transformed from electromechanical to the static relays, then came to the digital version, digital relays, numerical relays, and now it is intelligence electronic device, IEDs call it. Now the total substation, total electrical substations at the power plants under substation automation system. And most importantly, the difficulties of those electromechanical relays have been overcome by the introduction of beautiful algorithms, beautiful fuzzy logics. For example, differential relay. In those days, it was very difficult to provide the inrush restraint or the harmonic restraints and true fault stability. But now with different algorithms, the relays are working much faster. Subcycle relays, all are subcycle relays, working in milliseconds. Within 4 or 5 milliseconds, they are detecting whether it is a CT saturation and whether it is not a CT saturation, whether the fault is through fault or whether it is a in-zone fault, and whether it is a magnetic inrush phenomena or it's a overfluxing phenomena. Because of that, the harmonic restraint has to be operated. Wonderful logics and wonderful algorithms operating in microseconds and giving stability to the protection. This is just an example for where I worked. Apart from that, in every field, now IC 61850 has come up. Interoperability of the IDs has come up. Now goose networking has come up. Goose signal is giving, is not only controlling, it is also giving trip commands. So wiring, everything has come down. It has become easier to implement and lot of advantages. Everything is faults, alarms, everything is recorded. You can analyze the system, you can play back the fault records, and you can verify whether the protection relays have operated correctly or not. At the same time, there is a risk of cyber security. So try to avoid these systems to be connected to internet or take sufficient precautions, firewalls and all. So a lot of advancement has taken place and a lot of easiness has come out. A lot of efficiency has increased. Analytical ability of the engineers has increased, and it is giving its fruits. Now coming to the process, power generation process, steam cycle, boiler efficiency, turbine efficiency, all the process control, that is also, even the excitation control system, that has become digital now. One more disadvantage now as an engineer we are facing, that in our early days when all was static almost, and the circuitries were available in manual, it was very good. We used to do troubleshooting much easily. But now the new generation engineers are facing some problem. I also faced some problem later on when everything became digital, all software based, password protected. It has become a monopoly of the OEMs, which is very unfortunate. And they are not open at all, giving no access to the customers. Maybe some standard may have to come up, whether every OEM has to follow certain protocols, certain things, certain aspects which has come up for the relays, for the IEDs. Similar thing in the control system, I think will come up, or maybe might have come up by the time. But so long as it is working fine, it is of a boon. It's a boon. Really wonderful facilities in all the digital system, digital distributed digital control systems, and the tuning of the control system as BID tuning of the control system has become very easier now, and monitoring of the system and everything. Now coming to the another aspect of asset monitoring. If we only speak about electrical assets, partial discharge, online PD is a great help for the detection of the deterioration of the insulation. Even end winding vibrations of generators is a very good tool, and you can predict whether there is a trouble in that. In the next opportunity, you can look into the integrity of the overhang winding. Then tan delta, online tan delta of transformers are nowadays available. In the dissolved gas analysis, DGA, it's a very good tool. Online DGA, offline DGA is of course there. Online DGS has also come up, and the technology has brought the testing engineers delight in such a fashion. It's now becoming very easy, but more stress is given on analytics. Now all the testing equipments, whether it is a trans ratio tester or whether it is a tan delta capacitance measurement equipment, high voltage equipment, or a oil PDV measurement equipment, all are communicating with the computers. They are all smart, giving a lot of analytics and guiding the operator while using the testing equipment. So it has bring in efficiencies, it has bring in a lot of easiness for the operators, and at the same time the assets healthiness is monitored very accurately, comparing the past data based on the big data they have. They're giving their analysis, the equipments are giving its analysis, which is very handy, very helpful for the engineers, site engineers to take decision. And at the same time, the asset monitoring is giving confidence to the plant operators, and it is reducing downtime, At the same time, it is unnecessary maintenance, unnecessary avoiding unnecessary maintenance, improving the efficiency. Now, IoT based lot of things has come up in power sector also, in power plant also, and though these are all in incubation stage, and I hope it will be much more useful. Of course, it has a cost, but old retrofitting in old power plants may not be that much cost economically viable. But in modern new power plants, even the country is adding 80 gigawatt of thermal power plants by 2032, 3032. They are all those modern amenities will definitely come up. The IoT based sensors will be there. Temperature, pressure, vibration data. Vibration analysis is one of the most important application of the cutting edge technologies, and it is the analysis is making the operators job very easy. The signature analysis, now the inbuilt vibration sensors are giving those. Otherwise, in our times, lot of equipments have to be mounted. We'll have to take a shutdown of the machine. The machine will come on standstill, then put all those probes, and but now the inbuilt probes which are there for the regular monitoring, their signals are being taken, and a lot of software based programs are there. They are giving the trend analysis, they're giving monitoring these capital equipments, and guiding the operator also to look for what to look for and not. Now, digital twins. Nowadays, we all are using simulators. Even company like GS is here. We have 3 simulators: 500 megawatt, 660 megawatt, and 800 megawatt simulators here, and which is very helpful not only for giving training to our engineers, but at the same time to analyze what has happened, what has gone wrong in the process. So you can, through digital twin, you can simulate, you can do the virtual, you can do the, can make real-time virtual replicas of the power station, power equipments, the plants, and all your assets. We are using simulators very widely now, but digital twins and its applications are still on the nascent stage. I hope it will come up effectively and very helpful for the new generation. Now, another thing, drone technologies. I personally used drone for so many applications in power plants. Even for the concrete, the civil concrete inspection of the high-rise chimney, of the high-rise cooling tower, their concrete conditions, the structural deformity, where people takes time and all risky things to reach there, the drones can be very effectively utilized. The drones can also do the measurement of the coal stock. Most important applications will be the drones on the solar PV panels. Hectares of areas are filled with millions of solar PV panels. And nowadays, the system is available. If you fly the drone across the field, it can capture data from all the solar panels and find out where is the fault, where is a defect, whether it's a short diode defect or any sorts of defect, high temperature, whether it is a thermal scanning also is done, and in no time almost. Manually it is very difficult, takes months of time to analyze, to get those data, which you can take in few minutes of time, minutes or an hour. And with backup software algorithms, you can have fantastic analytics which helps you pinpoint the defect and attend the defect quickly and significantly reducing the downtime. So now distributed generation, decentralized energy systems everywhere, whether it is solar rooftop, net metering, microgrids, battery storage, everywhere these software-based applications, which is making the effectiveness of the system very
Yeah. 1 minute, Somesh.
us.
Yeah. We'll have to give the audience also to ask some questions. So
Okay. Then I will have to close it by
Channel-
within 5 minutes.
5 minutes would be great.
Okay. Then I'll be closing. Just
All right.
let me think over whether there is anything I should
Yeah, okay.
add to.
Please do.
Uh, flexible operation. One of the things which came in my mind. Nowadays, because of this intermittency of the RE, the coal plants have to be made more flexible. Means the ramp rate should be very high. The technical minimum of the plant should go down as low as possible. Now 55% to 40%. And these are the requirement of the grid and has to be done. So for that, lot of upgradation, lot of new control systems, combustion optimization is required, and that are being done now through different upgrades. So technology is adoption in this for this operational excellence is very much required. And coming to the sustainability part, that is whatever you are polluting, you will have to capture all the exhausts. Now the demand of the day is, earlier it was you can have a certain amount of SPM will have to be restricted. You'll have your flue gas output, whatever is coming out of the chimney. Now the demand, now the aim is how to capture the total flue gas and utilize it. And the major thing is sulfur SOx. For that, flue gas desulfurization plants are being adopted. NTPC has almost is going for all the units, and the outcome will be very minimum SOx emission, less than 200 milligram. Output will be gypsum will be the product, but we cannot be only satisfied with SOx emission control. We have to control NOx and more importantly the CO2, because the maximum emission is CO2. 1 unit of electricity produced through coal produces 800 gram of CO2, 800 to 900. And power plants in India produces more than 1,300 million tons of CO2 every year. So if we can capture the CO2 capture and utilization technology, that has to come cost effective, so that the ill effects of coal-based power plants can be minimized, and the coal-based power plant can survive for many more months, many more decades. And there are a lot of byproducts NTPC is doing by capturing CO2, though these are all in small scale, 20 tons per day or so. And then that CO2 is blended with hydrogen and making methanol, which can be used for with the crude oil, with the petroleum products. So methanol, ethanol productions by capturing CO2 from the flue gas of the. So these are all new technologies coming up, which will help in sustaining the coal-based power stations generation. And then from ash also, we are doing a lot of utilization of ash, cement, brick, road building and building blocks. And so environment, society and governance, ESG rating of the power plant owners have to be maintained. For that, business to be done in such a manner, applied all the state-of-the-art technology, so that it can enhance the ESG rating. And last not the least is the training of our young engineers, young technicians, and here the utilization of digital technology, whether it is through augmented reality or through virtual reality based training modules, which will be very handy and effective. So skilling and reskilling through different digital medium will be very fast and very everlasting, and that has to be utilized, because we need more and more skilled labor in these diversified fields. Even if we go nuclear also, there also we need a lot of new, because that talent we are not having like the talents we have for the coal-based power stations. So in this diversified field, we must have to give more emphasis on training through digital medium, training through the state-of-the-art technologies. So I think with this I will close here, and will give opportunity to the participants to raise question if I can satisfy their queries, or if you have any, I can help you out. I am not the authority in this. I am not a little bit of electrical engineering. I know that too, maybe 1% of power plants. But
Thank you very much. I think
sir
now
has decided to choose me. That's my honor.
I request Professor Ranjan Ganguly to please conduct the question answer session.
Thank you very much, Mr. Bandyopadhyay, for this illuminating talk.
Thank you.
You nicely took us through the landscape of this changing power scenario and the advanced technologies that are being used. So the floor is now open for questions. I know that there are many experts in the field who are in the audience today. So we do expect good interaction and almost like brainstorming. So questions, please. Professor Shudipto De, yeah, please go ahead.
Yeah, unfortunately, my camera is not working. That doesn't matter anyway. So, sir, it's a nice presentations of the overall perspective of the Indian scenario. So, I have some issues because you have very good practical experience, state of the art exposure. Number one, you have, I don't know because I could join only some few minutes later, whether you have discussed about the prospect of supercritical technology with respect to the future Indian power scenario. Any comments, sir? May I finish up my questions or one by one?
Supercritical technology, ultra supercritical technology. These are the technology which is only used now. No more people are going back to the subcritical or the so supercritical, and then people are ultra supercritical. That is the thing.
Yeah, the future installed plants are supposed to be in that directions only.
Yes,
That's an important thing.
yes. And now the government of India has standardized the unit size also, 800 or beyond.
Yeah. Okay, so that is the other point that is converging with my ideas. Number two is, what about the nuclear future prospect? Because according to the renewable resources, we can never meet the target. At
Yes.
2070, that has been announced. None of us will be living, at least yeah, my age and your age. I am sure. So the
I
target
mean,
has been fixed on net zero. So what about the nuclear options the government is planning? The small nuclear plants or something like that?
my personal opinion, I am a proponent of nuclear technology. The reason behind that if you see the Fukushima Daiichi, this disaster, there was no casualty at all because of the nuclear disaster. It was all because of the tsunami and all. If you look back in the history, only 3 nuclear accidents took place. And how many nuclear reactors are working across the world from 60s? More than 400-500 nuclear reactors are working. In India also 25 nuclear reactors are working. Some of them are as old as 1960s, 70s. Tarapur and all. There has not been a single accident so far. Definitely we'll have to be very cautious about this, but with latest generation 4 reactors, the safety is much more. Now coming to SMR or not, small modular reactor or not. My as a power generator, I should go with the large size reactors. It is techno commercially more suitable. At least the reactor size should be more than 1.5 gigawatt or so. Like in Kudankunal, we have 1000 megawatt reactors. That is, India has a technology which is PHWR, but worldwide PWR is the technology which is more common and more efficient, and they are 1.1 to 1.77 gigawatt scale of large reactors will be very much essential for countries like us. SMRs can be used for industrial uses, but it is also in the very nascent stage. No commercial SMR is there in the world till now. But these PWR reactors of high capacities are established for the decades. And now, after this renewable and these grid incidents of the Texas incident, the UK experience, now the Spain and Portugal experience, even Germany is thinking of opening up its nuclear reactors. Japan, they shut down all the reactors after the Fukushima disaster. Now almost 13-14 reactors are generating because they suffered a huge amount of foreign exchange because of the nuclear power going down. Huge amount of gas and oil import bill has, and now with this changing scenario, they are again going back. And China, I am not talking about them. They are the now pioneer in nuclear also, pioneer in hydro, pioneer in everything, whatever you call it. So if you want to learn something, you'll have to learn from China, not from any other country. They have added in last 10 years 30 gigawatt of nuclear plant, and all are generation 4 nuclears. nuclear reactors, Hualong 1, Hualong 2. So we must have to learn from them how they are advancing. And recently, that Director General of IEEA, he visited China and particularly this new generation Hualong reactors, and they are doing it in 6 years' time. One of the most important thing for nuclear, the gestation period is very high. Right now, two reactors are going on under construction. One at EDF France, one in at USA Georgia, Boktal. They are already in construction for last 10 years, 12 years, like our Udanguri. But China is doing in 6 years repeatedly. Not only inside China, outside China also. They have done two units in Karachi nuclear complex, Walang Walang 1 reactors in 6 years time. So we'll have to adopt this. The future will be in nuclear, so long as nuclear fission or a fusion or any other technology disruptive technologies or source of energy does not come up.
Yes, sir. I'm getting full confidence from your feedback, because in class also I tell that as many people have died from the flying, lesser people have died in nuclear explosion. We are still flying but not accepting the nuclear. I will.
What about terrorism and war?
Yeah. So we should not be afraid of nuclear, at least. The lesser amount of casualties there, and much more prospect is there with respect to the base load, because the fluctuating loads will always be there. Base load control is very much important. Professor Ganguly, I should not ask any more questions now. If time available, I can come on later. I have some other issues also. Anyway, so you can go to the next person. Then later on, if I time permits, then I will go.
Anyone else who's well, I had a question. Like, I mean, since you have been talking about that the next coal-based plant is gonna be super critical. What about the gas-based?
Gas-based, uh, till now there is a pause on the gas-based. But what my gut feeling is that if really the European countries are going has gone so much into the renewable and nuclear, if it comes back, gas will be available at a cheaper rate. It is only the price which is preventing. Otherwise, definitely gas is much easier, much less uh, dirty. Environmental pollution is less than half of coal, and the only thing, the availability and the cost, which is preventing us. If the global demand
And
goes
what?
down because of renewable, then gas will be cheaper, and then we should be able to. So we have 25,000 megawatt of gas uh, plant in our country. Most of them are not working. Even they are using, they are used as a peaking support.
Peaking support, yes.
So, but if
in
gas
in in, uh, in the combined cycle mode, because like, I mean, peaking support isn't, I mean,
open cycle,
it's in open. Okay. And
combined cycle, sometimes they are also coming, but it is inefficient.
right, right. And how about the IGCC? What's the stance from on behalf of the government? Coal gasification.
Coal gasification, coal bed methane and coal gasification, those two efforts have been taken. Coal India is also taken up these two separate projects. But coal gasification, not in a, it has to come up, not matured enough now, till now.
Is the what's the bottleneck? The initial investment, is that the bottleneck, because or the technology?
Actually, I am not the right person to tell you this.
Okay.
Okay,
No,
I am
that's
not,
fine.
I am not fully aware of the bottlenecks, but it has to come up, not coming up till now.
Mhm.
Coal India is doing something on that.
Okay. So Any further question? If not, then we'll go back to Sudiptoda. Sudiptoda is always full of questions. So, uh,
Oh,
yeah,
yeah,
Sudiptoda, please go ahead.
yeah.
On
Actually, we teach subjects from rather our experience from the papers published, book, etc. But whenever you get a senior expert person from the field itself, that becomes very much interesting for me. Another issue, sir.
What
Flue gas,
about?
what about the flue gas desulfurization (FGD)? That has
Yes,
been made compulsory for the plants, but there was some issues related to the per unit cost increase and actual acceptance in the real field. What is your comment?
my view, if you want clean atmosphere, clean air to breathe, you have to pay for it. So definitely introduction of these new initiatives to clean our atmosphere, our air quality is a huge, I mean, burden on the electricity operators, and it is being passed on to the consumers. So whether it is really required, what is the effect of, because Indian coals are having very less
that's the question.
sulfur content, more less than, I mean, 0.5%. So whether really it is required for Indian coals, so that was a debate. But as per the notification, still now the notification is on. So everyone has to put FGD. NTPC already putting FGD in every uh, units. But there is a study going on, which I think the Niti Aayog also has recommended to the Power Ministry that let us first see the effect of the SOX after commissioning of the running projects of FGD, and then we'll decide whether to go ahead for the rest of the units. But that recommendation has gone to Ministry of Power. Ministry of Power sent it to the Ministry of Environment and Forest. But till now, no such directions and notifications has come up that it will be delayed. But definitely, it has been delayed by decades. Now the target is 29, 28, 29. My take is if it is less than 0.5, wherever the sulfur content is less than 0.5% in the coal, we can avoid this much of investment, because ultimately it is uh, overloading, it is being charged on to passed on to the consumer. Affordability is the issue. So that is my view on this.
Yeah, that's the issue, sir. Why? Because when Government of India makes a plan of implementation, the real life power plants, then whether it is most priority or not, that should the practical senior experienced people like you should have some feedback from them at least, because FGT cannot be the priority of Indian sector. I guess so.
That's why that new study has come up, and moreover the FGD supply chain also is a very, I mean, we started with 0.5 crores of rupees per megawatt investment. It has gone to 1.5 crore now. Suppliers are not available. Supply chain is uh, very, got disrupted. Most of the things are not available in India, particularly the uh, what it is called, FGD main equipments. So considering all these things from different uh, corners, government got the feedback, and then they did the study, and the study result they are, even Niti Aayog is not recommending for further. So let us see.
Yeah. Another issue is the biomass co-firing.
Biomass co-firing. Uh, it I started in NTPC uh, What I look for is that torified pellet or torified biomass, which is very effective. Non-torified, I'm not advocating for non-torified one. But in India, torified plants are very rare. At least few years back when I started, that time there was no plant at all, no technology available for torification. It requires high temperature, around more than 400, 500 degrees for the torification of the biomass, and oxygen-free environment. The reactors, they call it reactors. So if you can use torified biomass, that is as good as coal. Its calorific value is very high. It's maybe you'll have to look into the other properties, but in the I mean Europe and US also, some of the plants they have run without any coal, only through this torified biomass. 300 megawatt units ran fully at full load with biomass. So there is no other issue.
Yeah. No, sir.
Thank you. I
can
think, Professor De,
Mhm.
I think let us conclude because we
Yeah.
have already quite a 10 minutes overrun. I think you can get in touch with Mr. Bandyopadhyay for further discussion. So may I request Professor Ranjan Ganguly to now formally conclude?
So thank you very much for giving us, illuminating us this on this emerging field of power sector. And we, on behalf of the academy, we'd like to thank Mr. Shomesh Bandyopadhyay, and we take this opportunity to give you this certificate as a token of appreciation on behalf of the academy. We,
It's my honor, sir.
as an alumnus of Jadavpur University, also we take pride in inviting you for this occasion, and
Okay, sir.
uh, we'd like to thank all the participants from the academy and outside the academy as well, and interacting with this speaker. So this is truly in line with our view of, or rather the um, uh, point of view of this academy to promote science and technology, and to appraise the fellow and others about the latest development in technology. So we are happy that we've been able to get a renowned person like you on our Technology Day presentation. So with this, I'd like to thank all of you. And at this moment, I will conclude the session.
Thank you. We got
Thank you. Thank
Dev
you.
was a big boon.
Thank you. All the best.
Thank
Yeah.
you.
Thank you.